Okay, let's take a look at problem 64. So the first thing I'm going to do is I'm going to change this to 3.64, and I'm going to save this file as h3 underscore your name. All right, now I'm ready to go. So here's the data. What the data shows us is wait times in a doctor's office that uses a tracking system compared to a doctor's office that does not use a tracking system. And the problem asks us, first of all, to compare the mean wait time. And by the mean, they mean the arithmetic mean. And in Excel, that's very easy to do. We just type in equals, and we use the average function. The average in Excel is the arithmetic mean. Then all I need to do is I just need to drag over this list of data. Close parentheses. And it tells me that the mean for the doctor's offices without tracking systems, the mean wait time is 29.1 minutes, or about a half an hour. Now, since I did that once, I can just copy that formula over just by this little corner here. I put my cursor on that corner until it turns into a line plus, and then just drag it over, and that copies the formula over, so I can see that my mean or average wait time for doctor's offices with a weight tracking system is only 17.2 minutes. So that is part A of the problem. Part B wants to know what the median is. So again, it's very easy in Excel. There's a function called median, so I just do median equals median, parentheses, and I drag that same data set, close parentheses. I'm going to center it to make it look better. And so I can see the mean, the median in this data set is 23.5. And if I just copy that over here, I can see that the median here is 13.5. So both mean and median are different measures of the central tendency of information. So then it wants to know in, that was A. Both of those are part of A. So I'm just going to highlight these so I can see what the answers are. And I'll just make them green. Okay. Now B, so that's central tendency. B wants to know about the variation within these samples. So it asked me for two separate measures of variation. Number one is variance. And again, very simple in Excel. All I need to do is equals VAR and highlight that data set again. Okay, I'm going to center that, and I'm going to get rid of some decimal places, and then I'm just going to copy it over. So one thing I can see based on variance is that there's much more variability in this data set than there is in this data set. The variance is much higher. Now it wants to know the standard deviation. Well, one thing I could do to find the standard deviation is I could just take the square root of this, and we can do that with Excel also. We could say equals the square root of this, and I'll center that, maybe give it one more decimal place, and then I can just copy that over. So I can see that, so this would be a standard deviation. This is one standard deviation from the mean. So one standard deviation of the mean in this sample is quite a bit bigger than this sample. So if we use the tracking system, we have a much lower average wait time and less variation in wait time. Another way that I can figure standard deviation is I can use the standard deviation function, which is just STDEV, standard deviation, parentheses. I'll highlight the same data set again. And I'll center that, and you can see, I'll copy it over, and you can see in both cases I get the same thing by using the standard deviation function or taking the square root of the variance. Now I could also take the standard deviation and square it and get the variance. So I could take equals this one, caret sign 2, that means square it, and then I'll get rid of some zeros. So either way, I get the same thing. So here's the variance using the variance function. Here's the standard deviation as the square root of the variance. Here's the standard deviation using the standard deviation function. And here's the variance as the square root squared. I'm sorry, as the standard deviation squared. I hope that makes sense. So I'm going to get rid of this one. No sense answering the question twice. So again, to find the variance, I do that using the variance function. And to find the standard deviation, I do that by using the standard deviation function. Okay, so C wants to know, what kind of conclusions can I make? Let's highlight this so we know that's B. C wants to know what kind of conclusions I can make regarding the weight tracking system versus not using a weight tracking system. And I can say that offices with tracking systems have shorter average wait times and less variation in wait times. Okay, so here's my average wait time, 17 minutes compared to 29 minutes, almost half as much. And here's the variation. One standard deviation is 9.3 minutes compared to 16.6 minutes, so there's much less variation. Okay, D wants to know sorry, what the z-score of this item is. Okay, so to find the z-score, we can use the standardize function. So if we click equals standardize, there it is right there, and then it'll tell you what it wants. X is the number that I'm looking for, so that's 37 in this case. The mean is 29.1. See, it says right down here, this is what I'm looking for. X is the unknown. Mean is this number right here. Oops, I'm sorry. So first I have to do X, then comma, then mean, then comma, and then standard deviation. Enter. So the z-score of this item here so what this means is that 37 is 0.476 standard deviations from the mean. So it's higher than the mean score. You can see it's higher than 29.1. If it was this one, if we did this one, it would be a negative number, which means it's a negative standard deviation from the mean. All right, that's D. E wants to know, what's the z-score for this one right here? So you can see that this patient had to wait 37 minutes in this system, and this patient had to wait 37 minutes in this system. So how far from the mean are they, even though they're the same? So what we'll do is we'll do the same thing. We'll say equals standardize. Here's the mean. No, I'm sorry, did it wrong again. Equals standardize. So first is x, that's the one we're interested in, comma, then the mean, comma, then the standard deviation. Okay, so I can see that my z-score in this case is 2.13 standard deviation from the mean. So what that means is you're much more likely to wait 37 minutes without a tracking system than you are to wait 37 minutes with a tracking system, because this 37 minutes is 2 entire standard deviations from the mean, whereas this 37 minutes is only a half a standard deviation from the mean. That's what a z-score tells you. Okay, so if you can do that, you should be able to do your homework.